Thank you all so much for being here at yet another Planet webinar. If this is your first time here, we do these webinars regularly every couple of weeks, and we talk about all things relevant to the long range weather forecast. And today we have a really exciting topic, which is El Nino, which is literally the most important driver of global weather volatility and, more importantly, predictable global weather volatility. So with an El Nino, you definitely can't say that you didn't see it coming. And so I'm going to show you today all of the exciting things that are likely on the way because there is an El Nino brewing in the tropical Pacific. So, a little bit of background about myself. My name is Dr. Hansi Singh. I am CEO and founder of Planet AI. I'm a scientist. I used to be at the US Department of Energy. I was also a former professor at the University of Victoria. I decided to start Planet because I really wanted to help bring real world information from research into useful applications in society. So, of course, weather impacts just about everything. And knowing the weather better, particularly weather beyond the 7 day forecast, I think is so critical to making our lives easier, making our societies more resilient as our climate continues to change. So let's move on to our exciting topic today. So we're going to be talking about El Nino. I'll first talk a little bit about what El Nino is, sort of the El Nino 101. And from there, we'll talk about the 6 month forecast for the Nino 3.4 index, some global implications of this forecast, regional implications of this forecast, and a couple of remaining uncertainties as we close out. So first of all, what is an El Nino? Many of y'all already know the answer to this, but for folks that don't, El Nino is a major, what we call a mode of interannual variability. What does that mean? It means that it is one of the ways that the Earth system, the Earth's climate system, fluctuates from year to year. That's what that interannual. Variability indicates fluctuations. Earth scientists always talk about variability. What we really mean is volatility or fluctuations. And the cool thing about El Nino is that it happens on these planetary spatial scales. The Pacific Ocean is literally half our planet, and El Nino occupies about 10,000 miles across the equatorial Pacific when it's at its height. So, an El Nino is when the equatorial Pacific Ocean is warmer than normal. There's this huge protrusion that comes off of South America. And La Nina is when it is significantly cooler than normal. The key ingredients for El Ninos and La Ninas are the trade winds over the tropical Pacific, the ocean thermocline, essentially what the ocean is doing beneath the surface or right beneath the surface, about the top 100 meters of the ocean. The warm pool, which is what we have in the West Pacific, and then regions of deep convection. Hi, Amina. Nice to see you. And so all of these ingredients are really critical for creating an El Nino. And so before I go into how those ingredients come together, I just want to say, well, El Nino happens in the tropical Pacific. Why is it so important? Because I don't live in the tropical Pacific. Well, the reason why it's so important is, first of all, it's highly predictable and it impacts weather around the world. And those impacts of weather around the world, because El Nino is highly predictable, those impacts are highly predictable. So, in other words, really, when we talk about El Nino impacts on the weather, you literally can't say we didn't see it coming because we really can't. These impacts are really significant and they reverberate across industries. So this includes insurance, agriculture, energy, water, mining, construction, logistics, you name it, El Nino probably has an imprint on it. And so it is just literally the most critical thing in the Earth system to understand that we can see into the future over the next months to approximately a year. So, what causes an El Nino? So, transitions between an El Nino, neutral conditions, and La Ninas happen when there are changes in these trade winds. So these are like normal conditions over the tropical Pacific. Here's South America. Here is Australia and Oceania and Southeast Asia. And so generally, in normal conditions, we have a lot of storms over this area in the West Pacific. And we have really strong trade winds that blow from east to west across the tropical Pacific. And the West Pacific is much warmer than the East Pacific. During an El Nino, these trade winds basically just slacken. And so when the trade winds slacken, what happens is this thermocline, which is essentially this separation between some cold water deep under the ocean and warm water near the surface, it sort of slackens. And so what that means is that instead of the East Pacific now being cold, because the thermocline is weakened, it is now suddenly warmer. All of this warm water from the West Pacific suddenly sloshes east. And as it sloshes east, it really puts on a show. There's some really cool wave activity that happens. And these aren't like waves on the surface of the ocean, but they're waves that you can see in, for example, temperature. And they're just beautiful. They're called Kelvin waves. And so, there's this huge kind of sloshing of this water that happens all the way from the West Pacific to the East Pacific. And suddenly there's this huge blooming of warm conditions, warmer than usual conditions over the tropical East Pacific. So, just in a nutshell, the trade winds slacken, the thermocline falls, and so warm water sloshes eastward. And you have a ton of feedbacks involved in the process, really cool waves, and suddenly you have an El Nino. So it's a very neat process, and we're going to watch it play out over the next few months. El Nino is also periodic. So every 2 to 7 years, that is kind of the period of time where we get a transition from an El Nino to a La Nina back to an El Nino. And notice that that is like a pretty big range. And this is why prediction of El Nino is so important. It's not like you can just expect it, say every 3 years like clockwork. It sort of does its own thing. And so predicting it is really essential. So why does El Nino matter beyond the tropical Pacific? How can this thing affect weather everywhere? Well, it turns out that this is because of something called teleconnections. The Earth system is highly teleconnected. When we say that it's highly teleconnected, we mean that things that are happening at one point in the planet um, affect the rest of the planet. And the way they affect the rest of the planet is through atmospheric and ocean waves. Once again, not the waves at the top of the ocean, but very specific energetic waves called Rossby waves. And so what happens is that these waves propagate and they impact, regions as far as, Asia Minor, Sub-Saharan Africa, South Africa, North America, South America. You don't see any impacts over Europe, but it turns out that there's many studies that show that El Nino also affects the NAO, and that, drives weather in Europe. So literally the imprint of El Nino is all over the planet. Another interesting thing, it doesn't show Antarctica, but it also impacts Antarctica. So this is a very global phenomena, and it's predictable, which what makes it really exciting. So before we get into the forecast, I just want to say something about how we are able to forecast the Earth system beyond 14 days. So your weather model, which is what you have on your phone when you look at your weather app, these atmosphere only models. They're very complex models. The physics-based models require a lot of computation in order to produce your forecast, but they only show processes and depict processes that are in the atmosphere. Basically, everything else, ocean, land surfaces, these are mostly treated as boundary conditions. If we want to predict beyond 14 days, we have to use Earth system models. These are much more complex models, but the complexity is important because it actually gives us components of the Earth system that have memory beyond 14 days. The atmosphere is very forgetful. It forgets kind of where it started from after about 14 days. The ocean, on the other hand, it remembers for centuries to millennia. So by adding these other elements in the Earth system, we can much better understand how the Earth system will evolve over the course of weeks, months, years, centuries, or millennia. And so these are the tools that we use when we are predicting weather beyond 14 days. Please note, we cannot predict day to day by using these tools. So these tools are very much week to week, up to a certain point, month to month, season to season, year to year, even decade to decade. There's a lot of work in the research community about what is known as decadal prediction as well. So this is the tool that we use. It's not magic, but it can be very useful for looking into the future beyond your 14-day forecast. So an El Nino is almost certainly on the way. So this is our forecast for summer 2026. We are seeing a Nino 3.4 index of approximately 1.2 degrees over the Nino 3.4 region. And this is for June, July, August. So, the middle of those summer months. And so our most likely estimate of this is that a moderate El Nino will develop by the end of the summer. This is one of those cases at this point where there really is a strong consensus among seasonal forecasting models here. So on the left here are predictions from ERI, the Columbia Climate Center. And, one thing you see, so this is the zero line right here. And this is kind of the threshold for officially calling an El Nino. And you can see that by JJA, pretty much, the most of the models are above this, kind of dashed line, and they're definitely above zero. So the Nino 3.4 index is almost certainly going to be going positive into the summer. This is the ECMWF forecast, which is not included in ERI, and you can see that they're even more bullish on El Nino. So they have this index by midsummer a little bit higher than ours. So our prediction is around 1.2. I believe theirs is closer to 1.3 or 1.4. And so, yeah, it's great that there's agreement. And I think that the reason why there is agreement is at this point already, we're starting to see, this kind of warm protrusion happening over South America. So these are current ocean temperatures, surface ocean temperatures, also known as SSTs. But we have actually been talking about this possibility of an El Nino since the fall. So this is one of our weather webinars, November 19th, 2025. You can find it on YouTube. And basically at that point, we pointed out that the conditions right now really look conducive to an El Nino because we do have some of this blob activity, so warmer than usual blob conditions happening in the North Pacific. We have near neutral conditions, a negative QBO. All of these ingredients seem to suggest that we are in some sort of not perfect analog, but a similar enough situation to where we were in 2014 before that super El Nino, that it was very likely that we would be going into some El Nino phase coming into the new year. And so I think this is what we're seeing. And yeah, I think that this is once again one of those things that when you put your models together with, really good research of the past, then yeah, you can do really great forecasts. And so I think that this was definitely on the books even at the end of last year. So how does El Nino impact global temperatures? Well, this summer, so we're looking at forecasts for June, July, August on our forecasting system. The summer is going to be hotter than usual. El Nino is almost always associated with warmer than usual conditions, pretty much everywhere over the globe. You can find some regions that are less warm, like for example, that area over Oceania. But generally, our planet is going to be warmer than usual this summer. And in fact, temperatures might be record breaking. The reason why I say this is because if we look at this is the global temperature record, and we superimpose on that in colors where El Niños and La Niñas happened. Here, El Niños are shown in this kind of dark red color. And you can see that, in years where we have El Niños, we usually break records or we come close to breaking records. And so, we saw that here, we saw that here, we saw that here. It's definitely not guaranteed. But, if you had to make a wager on it, you could say, yeah, probably, we're going to get into, one of those top X summers this summer. And of course, I mean, that's just the El Nino starting. So, we can expect probably a lot more temperature impacts if it continues to strengthen, which we don't quite know yet exactly what that trajectory is going to be. So El Nino also has some global impacts on precipitation. So I'm just going to go over a little bit of the theory, teeny tiny bit about what we tend to see in precipitation. So in the tropics, we have these things called the Hadley cells. The Hadley cells are what causes a lot of rain in the deep tropics right near the equator and a lot of kind of dry areas in the subtropics, right? Like the Sahara Desert, for example, or the Mediterranean. And then also it creates conditions for the jet stream to occur at a particular latitude. Usually, that's what we experience like in the US. If you live like anywhere north of California, it's what you experience is like weather, right? And so during an El Nino, what we see is first of all, these cells, they contract towards the equator and they strengthen and they rise up. And so when they strengthen, that's what leads to often drier than usual conditions in the subtropics. Often rainfall in the tropics, even if it's not more than usual, it is often more intense just because the cell is just so much more energetic. In fact, it's so energetic that the tropopause rises. El Nino years are just really, the atmosphere and the Earth system putting on a show. And so, yeah, we'll see the tropopause rising. It'll be very exciting as we watch this happen over the course of the next few months. And then, in the course of these Hadley cells rising and contracting towards the equator, we tend to see that the jet stream tends to move further towards the equator. And so what that means is that some regions further away from the equator get drier, some regions closer to the equator get wetter. And so those are generally the rule of thumb that we can use to understand some of the implications for precipitation. And then the next few slides, I'm going to show just go through some of those implications for precipitation associated with El Nino. So, in terms of Southeast Asia and Oceania, and El Nino is almost always associated with drier than usual conditions. So, you can see this in our forecast for the summer. This includes Indonesia, Papua New Guinea, Malaysia, Thailand. That is definitely showing up over the summer. We also see drier than usual conditions over southern Mexico and Central America. Keep in mind, the Panama Canal is an area where there is a lot of vulnerability in terms of water. And so, this is an area to keep an eye on over, the next year because chances are there's going to be some water stress. Also note, this is a huge kind of agricultural region, and so, water stress can be anticipated there as well. If we look at South America as a whole, generally with an El Nino, we see drying in the north and wetter conditions in the south. And one thing I'll note here is that Colombia has just been getting inundated with rainfall. The coffee crop there is going to be lower than usual this year, the Arabica crop. And so probably they are really looking forward to some drier than usual conditions. But in general, of course, drier than usual conditions can be associated with, water stress. And so this is also something to keep in mind for these regions in northern South America, northern Brazil, Colombia, Venezuela, etc. And then, of course, for southern Brazil, Paraguay, Uruguay, Chile, Argentina, as we move into the fall, especially, we can definitely anticipate some wetter than usual conditions over some of these areas. The Sahel always responds very, very strongly to El Nino. So I've highlighted the Sahel in this box right here. And so the Sahel, which is the area directly south of the Sahara Desert, is a very vulnerable area. There's a lot of subsistence farming. It does dry during El Nino years. Also note though, something that's very interesting is that over West Africa, the summer, the conditions happen to be drier than usual, which is not always an El Nino phenomenon. Sometimes it is. But note that in the fall, we can probably expect this region to be wetter than usual. So we're going to keep an eye on that. That'll almost certainly pop up as this El Nino strengthens. So now let's look at South Asia. South Asia, over the next few months, is going to experience its summer monsoon. And in El Nino years, we can generally expect that the South Asian summer monsoon will have a later onset and it will tend to be weaker. And so this region will be at greater risk of drought. There is some interesting research to show that the off-season precipitation at the very, very, very south of the continent tends to actually be greater during El Nino years. But in general, most of this region, South Asia, does dry in El Nino years. Hurricane and typhoon activity, what can we expect from that? So, in general, in El Nino years, we tend to have a mild Atlantic hurricane season and a really vigorous Pacific hurricane season. So, over the Atlantic, and you can, if you take a look at that earlier slide where I showed the whole planet, you might remember that SSTs were cooler, or not cooler, but just not as warm over the Atlantic. So SST anomalies, ocean surface temperature anomalies were pretty small. Um, Moreover, during El Nino years, we tend to have more wind shear over the Atlantic and greater atmospheric stability. All of these things are not conducive to cyclogenesis, the formation of hurricanes. And so generally, the Atlantic tends to be quiet during El Nino years in terms of hurricane activity. In the Pacific, on the other hand, we really do anticipate greater cyclogenesis. So this includes, there's many reasons for this. This includes warmer ocean temperatures, of course, but also weaker wind shear and greater convective instability over the Pacific. And so all of those will be conducive to cyclogenesis and potentially more landfalling hurricanes as we move into summer and we move into the typhoon season. If you start going through the literature, El Nino is super exciting. There's tons of, papers on the impacts of El Nino. One that I want to highlight that's really interesting has to do with enhanced severe convective storm, hail, and tornado activity over the US. So it turns out that in years where we are going from kind of La Nina-like conditions into El Nino, so that's called a trans Nino. Basically, we're going from La Nina to El Nino. During a trans Nino, which is literally what we're experiencing right now and in the spring, there is good evidence of enhanced hurricane activity due to sort of mixing of dry air from certain locations combined with wet Gulf air. And so essentially the circulation patterns that are caused by El Nino are much more conducive to these big thunderstorms that give rise to tornadic activity and severe hail. So this is definitely something to keep in mind. We're coming on spring. And so, yeah, this is in the literature and it's potentially a risk factor to consider. That would be important. So we're nearing the end. We know that the coming El Nino, very, very likely. There's still uncertainties here. It's really important to remember that, we're dealing with science, not magic. We can't predict, everything or anything really with utter certainty. There is questions of really how strong will this El Nino be by the summer? By the summer, I think we have a sense, we'll probably be near about a degree, maybe a little bit more, of anomaly in the Nino 3.4 region. But yeah, what is this going to look like over to the end of the year? How will this develop next spring? And when I say next spring, I mean 2027, next 2027, into 2027. Are we going to get another Super El Nino? Yeah, all of that is up in the air. There's, a lot that we can speculate about it, but at this point, let's just put a question mark there and, kind of watch how this progresses over the next few months. And the other question is that it turns out that El Nino has many flavors. This is BAMS, which is kind of the Vogue magazine of the weather community of atmospheric scientists. And so, El Nino has faces, and there's many of these flavors or faces of El Nino, and they do have slightly different teleconnections. So that's another thing that we'll be keeping an eye on. Of course, our models account for these things, but of course, once again, predictions are never perfect. Models make mistakes. And so these are, some other uncertainties. So that brings us to the very end here. In a couple of weeks, I will be back to talk about the overall long-range weather outlook for the spring and the summer at our next webinar. You can find us on YouTube. And if you love forecasts and want to talk about them, you know where to find me. Find me on LinkedIn. Connect with us on LinkedIn. Connect with Planet on LinkedIn. And yeah, we would love to hear from you. And we have a couple of minutes for questions before we hop offline. Thank you so much. It looks like there's a lot going on in the chat. And yes, this webinar will be posted on YouTube.
Thank you, Hansi. It was great. And it's also very nice to see you here.
It's great to see
I just
you.
have a quick question, and I also need to leave soon. Because I also researched about Pacific SST on wind extreme events in North America. I'm wondering, have you looked at the impact of this El Nino on the wind in North America or other places?
Ah, wind impact. So yeah, wind is actually something that we do forecast. And so are you thinking, so you're not thinking about hurricane like or typhoon winds, but you're talking about specifically like windstorms. Is this, are
Yeah,
you talking about for generation for wind
yeah, it's like
power?
not very short time, more like seasonal.
Yeah.
Sometimes there are like seasonal drop in wind that they call wind drought, and it
Ah.
impacts wind energy production a lot. So yeah, that's what I was doing in my master's, and yeah, so I'm curious just about how would this El Nino would impact the wind. What I found was that normally the drop in the wind uh, is accompanied with El Nino kind of SST.
Yeah, yeah. I mean, that makes sense, right? Because I mean, we sort of expect the circulation during an El Nino to kind of, contract towards the equator. So areas that are used to getting weather, right? Like where they're just used to having the jet stream will be further towards the equator. So they won't sort of be getting that circulation. I am curious about the summer. The summer is always harder to predict in terms of wind than the winter. The winter, of course, is very like storm driven. That tends to be, large scale circulation driven. So yeah, I will probably have to look at that and get back to you because that is a super, super interesting area. We should talk.
Yeah, sure. Thank you so much.
Awesome. Um, Okay, so Sean has a question about the kinds of scenarios that are on the table for precipitation across North America. So, yeah, that is a great question. Generally, during El Nino years in the winter, we expect more precipitation over California, the US Southwest, and the US South. Please note, however, that often these enhanced precipitation years, they can be then followed by a major wildfire year, especially for California. So it's always kind of a mixed blessing to get a lot of rainfall because at that point, you end up with a lot of vegetation. And if you have a dry period, then it just all dries out and becomes fuel. But yes, that tends to be the precipitation impact of El Nino, though we tend to see that more less in the summer and more into the fall. Thank you, John. Nice to see you too. Okay, well, great. Thank you all so much. I think I caught all of the questions. And yeah, really excited to continue to converse with y'all. You know where to find me, and have a great rest of your day.